This is a patent by Samuel Friedman. It issued in 1957 and is called Process for Producing Lead-Zinc Alloys. Gosh, doesn't seem too related. Except that what this guy was doing, see in the 50s, the big push was two things, aluminum and plastic. Okay, remember when we were young, get into plastics, young man. Okay, but aluminum cookware and all kinds of stuff was coming out here. This was the big rage for the technology age of the 50s. And what Mr. Friedman was working on was the first practical low-temperature solder for aluminum repair. And so he came up with this amazing stuff, which he eventually brand named Chemalloy. And this is a special lead-zinc alloy. For those of you who know a little bit about metallurgy, lead and zinc really don't like each other much. If you try and combine them, you get this brittle mess that really doesn't do much. And he found a way of alloying these two metals and that produced some very, very interesting behaviors. Not only was it an absolutely superior... Okay, go ahead.
This was, I saw a free energy unit based on using these alloys.
Yeah.
It produced continuously about 1.5 volts, ran forever, did not need to be charged.
Exactly. I'm going to get to this. I'm going to show the whole thing, yeah. I'm going to go through this patent and show the whole thing. Basically what this alloy is made out of is there's absolutely nothing exceptional about it. It's made out of brass, aluminum, solder, silver, zinc, and nickel, and a waste product from copper manufacturing, typically called copper slag, which is a copper oxide, yellow sulfur, willow charcoal, and commercial muriatic acid. So it doesn't have any, strange, expensive components in it. And when you alloy all of these things together, you get a material that acts as an absolutely superior aluminum solder. You don't have to flux anything. You don't have to brush off the oxides or anything. It has the flux in it, the muriatic acid. It has all these things. It will bond to any of these metals because they're all in there. But if you take a good look at this material, gosh, if I was going to build a battery, what would I want in it? Well, gosh, zinc and copper, aluminum and carbon. I mean, all these metals are in every battery you've ever looked at, including lead. And so what he found was that, go ahead, next slide, that when this is the second patent that issued on the thing again, and after talking about the various objects of the patent here and about how fantastic an aluminum solder it is, we can get down to here, and it says another object is to provide metal alloys which in the presence of moisture cause the conversion of the latter into escapable hydrogen gas. Another object of the is to provide a metal alloy which electrifies and decomposes moisture on contact or during immersion. Okay, next slide, Jerry. This material had extremely unusual electrical properties. Here's the material. They sold it as an aluminum solder. You just buy these things. The stuff melts it. In spite of the fact that it has components in it that melt as high as 1200 degrees, the alloy itself melts at around 500. You just heat your aluminum up, stick the rod in, it just flows right in, right past all the oxides and everything. It still remains a more superior aluminum solder than anything that's on the market today. Go ahead. And here's some of the company literature. You can see improved fuel cell concepts, that it's able to produce electricity. Here he's showing, liquid firecrackers. It has a wide variety of astonishing uses. Go to the next slide. Here's an article that appeared in Science and Mechanics magazine by Samuel Friedman. He's trying to get people to be interested in this. Of course, industry was trying to stonewall the blazes out of him, so he says, gosh, student science fairs. Sounds like Bedini. Basically what they found was that when you, here he's saying here, put Chemalloy in plain water, produces about half a volt at 200 microamps. And one of these rods, Every rod will produce half a volt at 200 microamps. Now, and when you think about that, that doesn't seem to be too much to write home about. It's just that the material acts holographically, and when you powderize it to what they call 1 million particles per pound, every single particle will do exactly the same thing, about half a volt at 200 microamps, so that when they put the powder in water, it produces continuous production of hydrogen and oxygen. You can see here it says, to date, the capability of Chemalloy to generate electricity in water has been observed for 7 continuous years, and no limit is known. The liquid, rather than the metal, is the substance which is consumed and must be replaced. So the material acts catalytically on water and is not acted upon at all by hydrogen or oxygen or plain water.
By changing the constituents of the metals, you can increase the efficiency dramatically.
Absolutely. So these are just the beginnings of this. Obviously, there's something, I mean, the whole world could be running on free hydrogen. I mean, all you have to do is make this metal, and the stuff makes hydrogen forever at no cost. So that is by far and away the simplest form of what I call superelectrolysis.